8,000 hertz. Okay. So we know a human ear will hear from 20
to 20,000.
to 20,000. This is if you're young. But now, at our age, I think we start hearing maybe 40,000. From 40 and above. Okay. So, ultrasounds. So, sound waves, what characteristic of sound waves? And if you want to draw any sound wave, it will be something like this. Huh? Characteristics, it has what?
Frequency.
Amplitude. Okay, amplitude. So what is amplitude?
The whole from up to the...
This is peak, sir?
It's wrong.
Trough here? Okay, peak to trough or peak to baseline. That means the amplitude. In machine term, it means what?
Power.
Means what? Power. You increase power. Okay, you increase power. Okay, so we know that it has an amplitude. What else it has?
Frequency.
Frequency.
Velocity.
Frequency, which is what?
Number of cycles.
So cycle, what is a cycle?
Where?
Peak to peak? Or trough to trough? So this is one cycle. And in 1 second, number of cycle in 1 second, we call it, what's the unit?
Cycles.
Hertz. Hertz, the unit? Hertz. Hertz. Okay. So we have power or amplitude. We have frequency, which, how many in 1 second, and we have
Velocity.
we have velocity. We have velocity V. We have
Wavelength.
wavelength. Wavelength is the distance from here to here, or here to here. This is wavelength. Okay. Now the question: which is variable? Which is constant?
Velocity is constant.
You got in mind. Velocity is constant. How to change the velocity of ultrasound? The only way to change velocity of ultrasound is by what? Changing medium. Yani velocity in air is constant. Can you change velocity in air? You cannot. But you can change the air. Okay. So what is the velocity in a human body?
1,500.
1.5
140.
4 0 unit. ايش هذا؟ units. Meter per second. So this is the velocity of ultrasounds in human tissue and blood. Okay. So this does not change. Does not change. What is the equation? What is the equation of velocity in general or speed? Speed equals what? Distance
Time.
over time. Okay? So velocity here equals distance, which is wavelength. This is what? Greek letter for? Huh? Yeah.
Delta.
Delta? Is this delta? Lambda.
Lambda.
Okay. So this is lambda. Wavelength. Okay. Velocity. This is the distance divided by time. Time. When we have frequency, which is 1 over second, or number of seconds over second. So times frequency. Okay? So, because velocity is constant, now if you increase frequency, wavelength will decrease to maintain velocity, which is logic. Okay. Now, let's talk about resolution. Ultrasound will send pulse, will receive then the pulse after certain distance. Based on that distance, and if we see, let's how ultrasound started. And this is a probe. It will send beam, pulse of beam. It will hit an head object. It will go back. The machine knows the velocity and it knows the time, because the time from sending and then receiving. Knowing the time, knowing velocity, it will know the distance of that object. Sorry? Okay. The distance traveled by ultrasound divided by 2 is the distance of that object. Sorry? Because it has to go and come back. Now, the brightness, is it too much bright, like calcium, or it's soft, like a thrombus, or so it depends on what?
Density or
Now it will send a pulse, it will come a pulse.
Yes.
it will not
At a
affect it.
distance or
I
at
am-
a density?
Amplitude. Higher amplitude of reflected wave, now we talk about amplitude. Higher amplitude, more reflective is the object, yani dense. So it was decided that more we make it dense. Before the density, there is the A mode. You know A mode in history, A mode. They said, okay, and instead of making a brightness, we will make it spike. So it will be like this. One spike, small spike. So this is the distance, and this is here is the amplitude. This is the ultrasound in the old days. You see something like this. You see high spike, low spike. You know, at this distance there is an object here. Then they change it to brightness, make it more bright or dark, and then they call it B mode. It will be different. It will be distance is here now, and then this is too much bright, this is less bright, this is brighter. It depends on the object. Now, this is a probe again. It will send one pulse here. Send, listen. Then another one here. Then another one. It will steer. This is, we call it steering. It will steer the beam. Then, نجمع هذول البي modes, put one, another one, third one, stitch it together. Then we have something called 2D. And we have what? We have one frame. We have one frame. We finish steering, we put all B modes together, now we have one frame of 2D. Good. Then we take another frame, third frame, fourth frame. How many frames we can take in 1 second? How many frames we take in 1 second? More frames we take in 1 second is better. صح? More frames. You play games? You don't play games. You play games? Okay. So, when I buy a screen for my son, he will insist on, I need minimum 120 refresh rate of the screen. I said, how come you want 120? A human eye can see maybe 30, 40, 50, I don't know. You know, they insist for gaming. The highest, the refresh rate is the highest frame rate. So you need frame rate so you don't lose small motion. It will be smooth. Now, frame rate, yani frames per second, what we call it?
Temporal.
Temporal resolution. It's a temporal resolution. It's resolution of time. Temporal resolution. Okay. So now if we talk about resolution, we have temporal resolution, which is how many frames we have per second. This is one type of resolution. Okay. Then we have the 2D resolution, which is what? And if you want to say types of resolution, yeah, you tell me types of resolution.
Spatial resolution.
Spatial resolution.
Axial resolution. The divided.
So we have temporal resolution. Temporal. And we have spatial. Spatial resolution. Now spatial resolution is the resolution of space. Yani that 2D thing. Okay. Now we have axial.
And lateral.
Okay. We have lateral resolution. Now, lateral resolution, for example, this is the probe. It will send one beam here. Beam will go, will come back. Then it will steer the beam. If it steers the beam too much, you take one piece here. We have apple here. This is apple. So you take one image, then you steer too much here. So you have two pieces of apple and something missing in between. Machine will have some intelligence and it will fill in the blank. So, or we will see some lines, black lines. So this is, we call it lateral resolution. More beam in a frame, the higher the resolution. The shorter the distance in steering, higher resolution. Okay, so you increase the resolution. You can increase this resolution. Now, we have the axial resolution. Now, axial resolution, you have this same apple, you send beam here. Now, axial resolution is the ability to differentiate between 2 points. Actually, this is all spatial resolution. 2 points near to each other. Axial resolution is you can see something here clearly and you can differentiate it from another object in the axial or the y-axis, vertical. Okay. This it does not depend on the beam steering. It depends on what?
Wavelength and frequency.
Frequency. It depends on frequency. Yeah, you want to improve this to the maximum,
Increase the number.
you increase frequency. You increase frequency. You increase frequency, you improve which type of resolution? Axial
Axial
resolution. Yes, you improve axial resolution, not lateral resolution. You will ask me, okay, let's use the maximum frequency for everybody. What's the problem of higher frequency?
Lower penetration.
Okay, so again, if you have an object, more frequency you have, more interaction. More interaction, more loss of energy. Loss of energy.
Attenuation.
Attenuation, yes, you have more attenuation more into heat, absorption. If I send this wave, this pulse of wave, or I send this pulse of wave, I have an object here, I have an object here. This will interact too much with this. It will generate heat, it will show me details, it will show me, this will not show me details, less axial resolution, but it will continue, less attenuation. It can go, because this interacts more, it will give heat and have more attenuation, so penetration is less. Okay. So if you want to use for a far object that you don't see clearly, you reduce frequency. Okay. Now, the machine will control the lateral resolution. by itself. It will give you the maximum possible lateral resolution. How can I improve lateral resolution? How can I allow the machine to have a better lateral resolution?
Sector focus.
Yeah, but nowadays the machine doesn't have focus, the new machine. So now, if your object is here, your probe is here, wave has to travel here and here and here and here and here to give you, you can improve the frame per second, the temporal resolution. You can improve it. If you improve temporal resolution, the machine has to send less number of beams. So you will lose lateral resolution. If you decrease temporal, let's say I need only 10 frames per second. Now, only 10 frames per second, the machine can send more in one frame. You follow? Now, but if you want to have both, you need good temporal resolution, good lateral resolution, take only this part. Narrow the sector width. Not only that, for example, you want the best resolution. This is why we say, for example, you're doing apical thrombus. You want the best resolution of everything, temporal, lateral, even axial. This frequency, because you don't need deeper penetration. What you will do?
Decrease.
This is the apex. Khalas, we don't need all this. You only send beam here. So you decrease the depth. Now, instead of the machine waiting for the beam to travel all the way 15 centi or 20 centi, now it will travel maybe 5 or 4 and then come back. So it can send more beams, more temporal resolution in one frame and more lateral resolution because more beams, and axial, if you increase the frequency, you increase it, you have a better axial resolution. So this is about resolution in 2D. Okay. This is why we have certain views to take it in certain ways. And this is why we decrease depth, we narrow the sector. Okay. This is 2D ultrasound. Now if we want to see other utilization of ultrasound, it's not only this. Echocardiography is not about 2D. 2D is a small part. What type of ultrasound we have?
Doppler.
Doppler. Doppler is a name of God. This is why if you write Doppler like this,
Capital T.
Capital, only capital, because it's a name of God. Doppler, you write it capital. Okay. So we have Doppler. Doppler depends on what?
Direction.
Yes, change of frequency. I send certain frequency, then I receive different frequency. Frequency shift will tell me two things. Direction and speed. Direction and speed. Yani, if somebody is coming towards me and sending ultrasound, so he's compressing my waves. It will become, instead of wide, become compressed, yani more frequency. So I know that he's coming. And I know he's coming towards me. And from that frequency shift, I can know his speed. From Doppler equation. If he's going away from me, then the frequency will decrease. And I will send a certain frequency, it will hit, but he's moving away, then the reflected will be lower frequency. From frequency shift, I know it is a lower frequency, it means he's going away. From that amount of shift, I know that I know his velocity. Now, if somebody is moving from here to here, but I am standing here, and he's moving like this, I send frequency. It came back. It will came back what?
Same as it was.
Same. Because he's not coming towards me or away from me. He's moving side to side. This is why, yeah, for example, if you see, this is the heart. You have regurgitation this direction. You want perfect velocity. You have to move your probe here, so you are parallel to the flow. Now, if you're not parallel, you can add a cosine of that angle. This is, we call it angle correction. This is angle correction. But again, with angle correction, we only allow certain amount of angle. Once
Up to 15.
Yeah, once you exceed, yani 20 maximum. 20 degrees is nothing, by the way. Yani, this is a circle. This is 90. This is 45. Yani 20, a little bit. Yani 23 هذه. Yani little bit, we allow around 20. If it's more than 20, there is a problem. There is under estimation of the velocity. So this is why it is extremely important, okay, to be parallel with the flow. Now, Doppler has many types. Give me one type of Doppler. What? Color Doppler, okay. Let's go by spectral Doppler. إيش يعني spectrum? Spectrum يعني if you see something like this, this is a spectrum, okay? So we call it spectral Doppler. يعني you have in a time, this is time, and this is what? Velocity. Okay. Time and velocity. Now, ultrasound machine is concentrating on certain area in the heart, measuring velocity by the Doppler, by spectral Doppler, and then you will see the velocity here, going up and down. This is spectral Doppler. Now, under spectral Doppler, it's two types. Now, it will be confusing for you, but you have to understand it very well, very well. You have the pulse wave Doppler, yani the machine will send a pulse and wait for the wave to come back. This is the heart. Probe is here. It will send a pulse. It will send it where?
المكان اللي تحددها.
أحدده by what? A sample volume. اسمه my sample volume. في خطين كده أحطهم ولا كده؟
لا لون
بالعالية
parallel line.
Okay. Okay. So this is our sample volume. Yani we tell the machine that send pulse wave, a pulse of wave, and wait for it to travel this distance and come back and give me the result of the speed. Now, the machine will send and it will stop listening to any other wave. It will close its ears. Nothing, ignore everything until certain amount of time sufficient for the ultrasound wave to go here and come back. Because we know the speed and speed is constant. So it will wait and ignore anything. And then we have the result, which is velocity. We have the velocity in this area. Then it will be plotted with time. Now the problem is we have something new come, because now the machine has to send and wait and receive. For example, if you have an object that is moving too fast, either toward the probe or away from the probe. For example, now the machine at certain point, it found an object here. Let me make it bigger, sample volume. This is my sample volume. Because sample volume has a depth. Okay, I make it bigger. I found an object here. After period of millisecond, it moved here. Okay? I can know direction, I can know speed. If after a period of few milliseconds, it moved here. Or moved here, I don't know, where is it? It disappeared, it's so fast. It's so fast, I could not make the direction. It is so fast. Because I stopped listening for a certain amount of time, I lost the direction, I don't know. Going up or going down. Now if it is going toward the flow, we have here baseline. This is a baseline. Anything above the baseline is going toward the probe. Anything under the baseline, it's away from the probe by convention. Now, the machine, how will draw this? Above or low? So what you will see something like this. This is baseline. Then you will see flow like this. Above and below. So even the machine does not know. Is it above? Sometimes it will think it's above, sometimes it will think it's below. Okay, this is a problem. What do we call this phenomena? Okay, so this is aliasing. We call it aliasing. Now you have aliasing, you don't know exactly how much velocity, you don't know direction. We call it aliasing. It depends on what? Aliasing depends on... Now, before we go on aliasing, the higher, we know the higher the Doppler shift is, the higher the velocity. Okay? So, that distance, if it is away, we need to wait more. If it is closer sample volume, closer to the probe, it will send and wait only until it travels here and come back. It will wait less. Okay, so number of pulse I send per second, how many pulse I can send per second is called pulse repetition frequency. The more I can send pulse repetition frequency, the higher speed I can detect by this pulse wave Doppler. I can send more because it is closer to me, I can send more. I can detect higher Doppler shift or frequency shift. Now, the limit, the maximum Doppler shift I can detect, we call it Nyquist limit. Nyquist limit. This is the limit of frequency. This is the Nyquist limit, is the maximum or minimum. Anything above that, don't answer, we will have what? Yeah. Nyquist limit is the frequency that you can detect Doppler. This is the maximum. Anything above this frequency shift, we will have aliasing. We'll have aliasing. Okay. Now there is equation for Nyquist limit.
PRF, not Divided by 2.
PRF,
Divided
Nyquist limit, frequency and Doppler shift يساوي pulse repetition frequency
divided by 2.
divided by 2. What does this mean? It means your pulse repetition frequency has to be double the frequency shift. Double, has to be double. Yani, in order to recognize this wave, you have to pulse it double its frequency. Yani, if you send one here, you pulse here. If you pulse here again, you know nothing. But if you pulse double, yani one here, then one here, or one here, you know that it's coming down, but then it went up. This is double the frequency, so you can know direction. Even if you pulse here, but then you more than double. If you here quadruple or 100 times, you can know exactly direction and Doppler shift or final speed. Okay. Now we don't have this problem in the other type of Doppler, of spectral Doppler, which is continuous wave Doppler. We don't have this problem because the machine will continue, it has crystals. So it will dedicate one crystal you send, one crystal you listen, all at the same time. I will listen at the same time continuously. Frequency is maximum. I will keep listening all the time, no pause for nothing. Frequency is maximum. I can detect speed, no problem. Now, usually, maximum speed can be detected by pulse wave Doppler. How much? Pulse wave Doppler, how much? أفضل حالات كان 2. Around 2. Usually nothing, no more than 2 what?
Meter per second.
Meter per second velocity. Okay, this is the maximum. Definitely this cannot be, for example, mitral regurg. You can never do this pulse wave because velocity of mitral regurg depends on pressure difference. 5, 6, it's too much. 5, 6 meters velocity. Okay. Continuous wave Doppler. What's the problem now if you understand everything we mentioned? What's the problem of continuous wave Doppler?
Cannot detect a higher
Maximum
velocity.
velocity on
No, continuous wave Doppler, no problem with velocity. It can detect
Any,
velocity.
anything on its way. Anything on its way, it will detect.
Yeah.
Yeah.
Cannot differentiate between components.
Exactly. Now, this is the probe. The probe what will do, it will keep sending in this line, keep listening in this line
It will
all the
detect
time.
anything.
So it will detect velocity
The same
here.
thing.
Now you don't know. This velocity came from here, came from here, came from here. You can never know. The only way to know the shape of the velocity, the direction of the velocity. For example, if you detect something like here and going down, away, and this is the heart, you will think, oh, must be mitral regurg. Okay, if it is, or if you detected your probe is here, and the aortic valve is here, and then you detected something like this, more triangular, you say, okay, must be aortic flow. Okay.
The gap shape.
It will not detect the point.
No, not exact location. You can never know exact
On the
location.
same line.
It will detect the higher,
Higher velocity.
the maximum velocity you will see. For example, it detects here velocity of 1, here velocity of 2. What you will see here, you will see velocity of 2. Okay, because it's continuous. Continuous you see full number. You will see 1 and 2, but you can know the maximum. Okay. Now we continue on Doppler. Doppler, there is a third type of Doppler. اللي هو Let's speak about color Doppler. Now color Doppler, it's the worst killer of image quality. Now, color Doppler is what? This is the heart, for example. You want to see MR. This is your sector here. Color Doppler is sample volume, it's pulse wave Doppler, but not one, maybe 100. It will put one here, sample, another sample here, another sample, and keep pulsing every sample volume within that sector and put a color code. Color code, yani going toward the probe is what color?
Red.
Red. Yani going here toward the is red. The brighter is the red, the higher is the speed. Going away, blue. Again, brighter is the blue, higher the speed. The problem is, you have so many sample volume. Yani, probe has to send pulse here, listen, send the libadha, and listen, libadha, listen. Oh, بعدين finish. Go next line. Next line. Your frame rate will go down like crazy. This is why we don't put color everywhere. Otherwise, frame rate will be killed. So we try to narrow it, and depth, decrease depth as much as we can. But it has to make sense. For example, you want MR, you have to include the LA, not part of LA. Maybe it's eccentric. MR will come back from here. Okay. So this is about the color Doppler. Again, Doppler is angle dependent. So we explain why it's angle dependent. It has either come towards me or away from me. It's angle dependent. Now, one more. I cannot give everything in one.